Okay, so we are going to solve two-step equations. So they're just like one-step equations, but there's an extra step involved. So we are going to recap, right? We have these inverse operations. So if I do addition, the opposite is subtraction. If I do subtraction, the opposite is addition. Multiplication and division are opposites. And inverse, remember, inverse undoes. Inverse undoes what was done. Okay, so here's some examples. Solve the following equations for the unknown variable. Okay, so we have to think about what was done. So first, they divided by 2, and then they added 3. So whenever we're trying to undo it, we want to go in, right? We want to do the opposite first, right? So think about like when you break apart a car to fix it, right? You like take apart certain parts and then you have to put them back in the same order. So the last step we did was add 3, so that's actually what we're going to do first. So instead of adding 3, we're going to minus 3 on both sides. This cancels out. We're left with x minus 2 equals 16. And then we multiply by 2 on each side because they divided by 2. And then we're left with x equals 32. Right? And we can always check that. So check, right? We have 32 over 2 plus 3 equals 19, right? We just replaced this x with what we thought 32 was. 32 divided by 3 is 16 plus 3 equals 19. 19 equals 19. Check. Nice. So we chose the right answer, and this is the beauty about math. You can always know if you got it right by just plugging it back in. All right. Solve the following equations for the unknown variable. So first we had this x, then we divided by 2.5, and then we added 3.2. So even though it's on the other side, we still did this first because this is order of operations, right? So this happened first, and then this happened second because of, you know, PEMDAS, order of operations. So you always want to think like the reverse, right? So for here, we have our equal sign, and we have minus 3.2. We're left with just x over 2.5 equals, and then this would be 1.4. And then we multiply by 2.5, multiply by 2.5. Oops. And you can do this with your calculator. So I have an app on my phone that a student told me about, TI-84 app. You could just search it in the App Store. So you can use a regular calculator, but I want you to get used to the TI-84 because that's what you're going to be using in all your tests and in your future classes. So we have 1.4 times 2.5, 3.5. So we have x equals 3.5. And we can check. So we have 3.2 plus 3.5 divided by 2.5 equals 4.6. So 3.5 divided by 2.5 equals 1.4. 3.2 plus 1.4 equals 4.6. 4.6 equals 4.6. Nice. Okay. Back side. So solve the following equations. Why don't you pause the video and see if you can do these, and then you can unpause it and see if you got them right. So I'm going to put my lines for all of these. Right, so this one we multiplied, or we divided at the end, so we're going to do that first. Then we're left with f plus 2.5 equals 6 minus 2.5. And we're left with f equals 3.5. Alright, here we're going to multiply. We have x minus 1 equals 7. Then we plus 1. X equals 8. Right? So this is a two-step equation, right? This is the first step. This is the second step. Right? And if you think about it, that's the reverse of the original, right? First step, second step. Okay. So here we had 16r minus 12 equals negative 4, so we're going to add 12 on each side. We're left with 16r equals 8. Make sure to keep track of your signs. And then we divide by 16, and we have r equals 1/2. Okay, solve the following equations by combining like terms. So sometimes it seems like there's more than 2 steps, but one of the steps is actually going to be like combining like terms or distributing or doing any of the other things that we've already covered. So for here, we have a like term here. So we have 2x minus 14 plus 4 is minus 10 equals 10. And now we can do our 2-step equation after we combine like terms. We add 10 to both sides. 2x equals 20, which means that x equals 10. Oh, I forgot a step. Divide by 2, divide by 2. Sometimes you get really fast at these and you just forget a step. So that's good when you can start to do that. Alright. We're combining like terms. Our j's, 2j minus 4j is negative 2j plus 10 equals 12. We're going to minus 10 from both sides. We're left with negative 2j equals 2. Divide by negative 2. And then we get j equals negative 1, right? And we know that a positive divided by a negative gives us a negative. Okay, let's try an application problem. Write an equation for the function described. The output of a function is 8 more than 3 times the input. Find the input when the output is negative 1. Okay, so the input is x, output is y. The output of a function is 8 more than 3 times the input. So we have y equals 8 plus 3x. So the output of a function is 8 more than 3 times the input. Find the input when the output is negative 1. So we're trying to find x, right? Find x when y equals negative 1. So we're going to set y equal to negative 1. And now we're trying to find x. So we're going to do our 2-step equation. We're going to minus 8. Negative 9 equals 3x divided by 3. Then we're left with negative 3 equals x. So x equals negative 3. So you want to be able, ooh, sorry, you couldn't see it that well. You want to be able to translate this into, right, words into math. That's a really important skill, and a lot of people sometimes mess up with that. So make sure that you are being able to translate between the 2 languages.